Hello everyone, here's a video on physical properties and physical changes and also chemical properties and chemical changes. So the first thing that we're going to discuss is what you see on the board in front of you, physical properties and physical changes. So as you read here, a physical property or a physical change, again I'm not using them interchangeably, but I can talk about them together. So a physical change, if you take a look at gold, right here, here's some gold, and the gold has a physical property that is yellow colored. It has a certain boiling point that's a physical property. Let's say the boiling point, I'm definitely wrong here, but let's say it's high up in the degrees Celsius. Okay, it takes quite a bit of heat to melt this stuff. So that's a physical property of this. It has a high melting point. So melting point being a physical property, then I'm going to physically change it, and I'm going to melt it down to a puddle or a puddle of liquid gold. Now, I didn't change it from gold to something else. I didn't change it from gold to liquid steel. I didn't change it from solid gold to liquid mercury. I didn't change it from gold to, you get the idea. So because I didn't change the identity, in other words, I didn't change it from gold, atomic gold, I've just physically changed it. Okay. Now, a physical change is important in this class because we'll study many of them. However, most of this class, since it is chemistry, we'll talk about chemical changes, which is really cool stuff. Okay. So some other physical properties, you'll notice this is a boiling point. Boiling point is a physical change, and boiling point is a physical property, and boiling is a physical change. Again, this is just water down here in the liquid form. Here's water up here in the steam form. Okay. Density is another physical property. So here's density. Oopsie. Here is density. It's something called a density column, and the density column that we have here has a bunch of stuff. So this is most dense. It's very thick. There's a lot of particles per volume, whereas this stuff, rubbing alcohol and lamp oil, is very thin. The particles are a little bit more spread apart, so there's not as many particles per volume. Okay, there's not many particles in the same amount of liquid. Okay. So this is a density column, and density is a physical property. Things that have high densities tend to sink. Things that have low densities tend to float. Okay? So if we take a look at ice water, a glass of ice water, so here's our glass, here's some water, and there's some ice cubes floating in here. Ice, which is just solid water, happens to be less dense than the liquid it's floating in. Okay, so that's an idea there of density being a physical property. Now, again, when we talk about physical properties and physical changes, there's a couple things going on here. Take a look at our picture. If a physical change is a change, but it doesn't result in new substances, there's a ton of physical changes happening here. You'll notice in our picture there's some crumpling metal, there's some breaking glass, there's popping tires, all sorts of things. Now, if this back here is indicative of some explosion, it doesn't look like it is, but there's some dark clouds here, so maybe there's something else going on here. Those are chemical changes now. That's going to lead us into the next substance, or next slide. But when we talk about physical changes, it's just things breaking, tearing, melting, crumpling. Again, you don't get anything new. You're just changing its physical state. Okay, so changes of matter, changes of state, are physical changes. So gas becoming a liquid and a liquid becoming a solid, that's a physical change where we take away energy. And then if I add energy into a system, I'll take a solid and I'll make a liquid, and then eventually I'll make a gas out of it. So we add energy to do that. But again, phase changes or changes of state, again, is all physical changes. Now, some other things about this. Whenever we have things that have a definite shape and a definite volume, those are solids. Okay, so solids have definite shape and definite volume. Definite volume but no definite shape, that's a liquid. Okay, so it can change its shape but doesn't change its volume as long as it's in a closed system. And these have no definite shape or volume, those are gases. Okay, and a high temperature state in which atoms, let me read this here, which atoms have lost most of their electrons, that's going to be plasma. Plasma, okay? So actually 3 states of matter that we normally come across, but a 4th one as well. Okay, keep going here. Now let's talk about chemical properties. And chemical properties are a little bit they're different because everything has its own list of chemical properties. and it depends on what it's combining with. For example, if I take this copper penny here, and I throw it in some hydrochloric acid, we would expect something to happen, and nothing does. Nothing happens with this penny and hydrochloric acid, okay? So you could swallow a bunch of copper, especially pennies, in your tummy, and almost nothing will happen for years and years and years, okay? Now, let's not talk about that, and don't do that at home, kids. Second of all, if you were to add nitric acid to copper, now it bubbles and it almost looks like it's boiling and reacts and produces this nasty brown gas and turns blue. Oh, it's terrible stuff. So notice the chemical property of copper does nothing here, but does something here. Okay, so the chemical properties have to be looked at on a case-by-case basis. Okay, so again, the definition relates to how much of a substance will react with other things, and again, we look at this on a case-by-case basis. Now, a chemical change is all about this class. Chemical changes or chemical reactions are what we do in chemistry. We're going to change something into something brand new, okay? But we're going to take the original pieces, the original particles, in other words, atoms or elements, and rearrange them in a different way. So what do you get? You get something with completely new properties, completely new substances from the old pieces. They have different physical properties, they have different chemical properties, and we have something that looks entirely different. Okay? Now, if we go one step further, this is one of the coolest experiments I know of. If you take sodium metal, notice this is a metal, okay? Here it is, it's a metal, it's solid, it looks silvery, it's very soft though. And then you take chlorine gas, okay, which is a heavy, dense green gas. Now, be careful here. If you were to eat some of this stuff, it's a bad day for you, okay? Your head would blow up or probably cause several chemical burns. If you were to breathe in a lot of chlorine, you would have another bad day because I don't think you'd have any left. Okay, it can be very toxic to you. So two things that will ultimately hurt you very bad or kill you, when I chemically combine them, I end up with, does anybody know what this is? It's table salt. So notice, here's a metal, soft metal. Here's a heavy, dense green gas, both potentially toxic. And you end up with something that can be ingested in small amounts for a regular metabolism, for healthy regular metabolism. Very strange. So those are those are chemical properties and chemical changes. Okay? I believe that's all we have for now. So if you have any questions, go ahead and contact me through email. Thank you.